Hello everyone, welcome to Knowledge Hub by Sri Chaitanya, where I was continuing our discussion on the first chapter in chemistry in the 11th class, which is some basic concepts of chemistry. Now, in this discussion, we have reached a point where we are going to discuss the next topic, which is concentration terms. Right? Now, what is concentration? What do you mean by concentration? And why concentration is important? Well, see, whenever you get sick, right? Whenever you get sick and you have to be given glucose into your blood directly, then there has to be actually some amount of glucose in some ml of water. Means, suppose if I have 100 ml of water, in that it is possible that only 5 grams of glucose has to be dissolved and that solution has to be injected. If this ratio of 5 grams to 100 ml is not maintained, it is possible that on injecting directly into your bloodstream, your blood may reject it and you may have health complications. Not even this, there are also medicines, right, where you can see milligram, right, like this written, right. What is this? This is the amount of substance in a particular solvent. Not only this, even in alcohol, which you get in the market, right, you will see it is written somewhere, it is written as 4% weight by volume, right. So how do we interpret this? See, these all things, milligram, this one, some amount of glucose, like 10 grams of glucose in 100 ml H2O. This is all what? This is nothing but concentration, right? And to express this concentration means if I make a glucose solution, suppose I made a glucose solution, right? And I am giving that solution to you. How do I tell you how much glucose in how much ml? Well, I can simply say that I have dissolved 10 grams of glucose in 100 ml of water, and that will be the concentration of the solution, right? In the same way, we need to know concentration of solutions, right? Like, I'll give you one more example. So we say that our blood has same osmotic pressure as 0.9% weight by volume solution of NaCl. Yes, even our blood is a solution which has some concentration of its constituents, and hence concentration terms is very important. So now let's get to it. Methods of expressing concentration, some of them are weight percentage, weight volume percent, molarity, normality. This particular concentration term we are not going to study now, we will study further in the next chapter. Molality, mole fraction and ppm. One by one in today's session, we are going to discuss each of these terms. Right. Weight percent. You can write it like this also, W by W percentage. Right. What is weight percent? Simply, it is the weight of solute divided by weight of solution. Now, this weight can be in grams, it can be in kgs. But remember, both the numerator and denominator must be in the same unit. So this can be also in grams or this can also be in kgs. And it has no units. Okay. Now before I move forward, let me just take an extra slide, right, and explain you another new concept. See, weight percentage is actually what they have written is weight in grams of a solute present in 100 grams of solution. So this statement you will see written everywhere in books, in many online lectures, but nobody will tell you why is this statement true and how does this statement come. That is where Knowledge Hub comes to rescue, and we are going to discuss this. See, the formula of weight percentage is weight of solute, weight of solution multiplied by 100. Correct? Now, I'm going to take an assumption and let weight of solution equals to 100 grams. Okay. So let the weight of solution be 100 grams. See, our aim is to cancel this 100 from the top 100 so that you can get some kind of a relation. So now weight percentage is weight of solute, and because I've taken gram in the denominator is weights of solute in grams. Right. So I can say this. What is weight percentage? Weight percentage is weight of solute in grams in 100 grams of solution. So this formula will be useful for you, but then sometimes you also need to know what is the meaning of it. So this is the actual meaning of weight percentage. How much solute in grams you have dissolved in 100 grams of solution. So if we are calculating weight percentage, right, and weight percentage has no units, obviously, because weight is in grams, this is also in grams, multiplied by 100, grams gets cancelled out, so it is unitless. It does not have any unit. A question here, I won't be solving all the questions, but some I will be. So let's see this. According to this question, it says that 20 grams of NaOH. You have 20 grams of NaOH in 30 grams of water. What is the weight percentage of solute? Now remember, in the denominator, you have what? You have weight of solution. Right. So what is weight of solution? It is weight of solute plus weight of solvent, right? Whenever you make a solution, solute plus solvent weights is the weight of solution. Now what has been given to you? See, weight of NaOH aka solute is 20 grams. Weight of solvent is 30 grams, right? So you have to find the weight percentage. For weight percentage, you need the weight of solution. So solute is there, solvent is there, add them up, you will get 50 grams. Now the field is set to calculate weight by weight percentage. 20 divided by 50 multiplied by 100, right? The zeros gets cancelled out, right? 4, you will get 40%, right? So that is our answer. So 40% weight by weight, right? In this way, you are going to approach weight percentage problems. So this is also easy. I will not solve this. I feel that you are well on your own to solve this. This is a very easy, similar question. Just try to solve yourself. Moving on to the next. Weight of solvent present in 300 grams of 25% weight by weight HCl solution. Okay. Let us see what we have to find. We have to find the weight of solvent, right? So write down weight of solvent is what we have to find. Present in 300 grams of HCl solution. So you have been given the weight of solution as 300 grams. And you have been given what? You have been given the weight percentage, right? What is weight percentage? 25%. So what does 25% mean? 25% means 25 grams HCl in 100 grams of solution, right? SOL raised to power n, that is my way of writing short for solution, right? So 25 grams HCl is present in 100 grams of solution, right? That is what we mean by weight percentage. So weight of solution is given to you, right? Weight percentage, okay, you can directly apply the formula here. We know that it is weight of solute by weight of solution multiplied by 100, right? Weight of solute is what? That we have to determine. Right. Weight of solution is given to you, right? How much it is? 300 grams. From that, find the weight of solute, and we know that weight of solution is weight of solute plus weight of solvent. So from that, weight of solvent can be written as weight of solution minus weight of solute. So let's have a go at that. So this will get cancelled out, right? So weight of solute will come out to be 75 grams, right? So now put that here. Weight of solution was 300 minus 75. So if you minus 375 from 300, right, 225. So weight of solvent is around 225 grams, right? So in that way, questions can be asked directly, indirectly, and when any one of these, like the weight of solute, weight of solution, weight of solvent, something like that can be asked. So this is one of the ways in which, so the answer is 225 grams, right? Right. So now let's move forward, right? This I've already explained. Weight volume percent. Weight volume percent means weight. Earlier there was W here, now it is V. Earlier there was weight of solution, now it is volume of solution. So weight of solute divided by volume of solution into 100, right? Now what is the meaning of this? That meaning is written here. Let us find out what meaning this is about. See, normally what I have found is, normally weight of solute is written in grams and volume of solution is written in mLs, right? So in most of the questions, this format is followed. So you also follow the same format. If weight is in grams of the solute, volume of solution, you can take it in mLs. Now this was the formula, correct? This is the formula, but we have to now understand the true meaning of this formula. For understanding that, let me go back to the previous pane, right? Window pane, and erase everything out. So now we're talking about weight by volume percentage, right? You have the weight of solute in grams for now, and you have volume of solution in mLs multiplied by 100. So let us pause here for a little bit. Tell me, if you want to cancel out this 100, what you can do? Well, simply you need 100 in the denominator, but in the denominator we have volume of solution. So let volume of solution in ml be 100 ml. Okay, one more thing, one small thing. See, in ml, the L has to be capital, okay? L always has to be capital. Do not write it like this, right? This is wrong. Liters, L is for liters, and for liters the symbol is capital L. This is milliliters, right? Just a small thing. I feel that many people do this wrong too many times, right? If you let the volume of solution in ml here, this gets cancelled out, right? So of solute in grams. So how do we define it? See, in physics you will learn and you will see that we define things like this, right? It's a common practice in physics. Chemistry, not that much, but okay, we'll use that also here. Right. So now, what I can say, weight by volume percentage is mass of solute in grams dissolved in 100 ml of solution, right? Right. So this is your weight by volume percentage, right? You can see weight in grams of a solute present in 100 ml of solution is weight volume percentage, and expressed in, see, 1 ml is equals to 1 centimeter cube or 1 cc. Okay, also remember this. So the unit of this will be grams per cc or grams per, right? That's why it's written grams per cc. So now 10 grams of sugar is dissolved in 250 ml of solution. Weight volume percentage of the solution. See, this is very easy. So even then I have to do it, so I'll do it. Right. So weight by volume percentage is, this is the mass of solute. So 10 grams by 250 mLs, right? This will come out to be 4%, right? 25 fours are 100, right? 4%. Volume percent, or I can say volume by volume percent. What is volume by volume percent? On the same lines as weight by weight, first we had W by W, then we had W by V, now we have V by V. No difference, right? Volume of solute by volume of solution. In this case, these volumes can be either ml, or it can be liters. Just both the units have to be the same, right? And because both are volume units, these units gets cancelled out, and this is actually unitless. There is no unit for this. It has no units. Right. Okay. A question for this also. Volume of ethyl alcohol present in 300 ml of 30% weight by weight aqueous ethyl alcohol is. I told you we will, and most of the case, when you get ethyl alcohol, the percentage of ethyl alcohol is written like this on the bottle, like 60% volume by volume. 60% will be written, and in the bracket V by V will be written on the bottle itself. Okay. So volume of ethyl alcohol present in, okay, this is volume percentage. So 30 you write here. 300 ml of aqueous solution. So solution's volume is given to you. So you have to find volume of ethyl alcohol. See, this is a no-brainer question, right? So volume will be 30 into 300 divided by 100, 90 ml. So when you mix 90 ml of ethyl alcohol in 300 ml, okay, no, not like that. When you use 90 ml of ethyl alcohol, then you get 30% volume by volume solution. Moving forward to molarity. Now this is the most widely used unit, molarity. So it is written as, if I want to write it down, the symbol for this is capital M. Yes, remember capital M, molarity, right? Units are moles per liter, right? What is molarity? What the way I like to write, number of moles of solute, okay, divided by volume of solution in liters. Remember, volume of what? Volume of the complete solution, and in what units? In liters. This is important. That is called molarity. Now suppose this volume was in mLs, right? Suppose the volume was in ml. Suppose you had VML. So how will you convert this VML into liters? If you have ml, you have to convert it into liters. How will you do that? VML multiplied by 10 raised to power minus 3, right? You will divide it, right? So it will be VML divided by 1000. Right? This will be your answer in liters. Right? So if you have to write it in ml, the formula changes little bit. So let me tell you how it changes. So this is your liters now, volume in liters. So simply substitute this part into this. If you do that, what you will get? Or I can say N solute. Okay. So I can write another formula for molarity as, what formula can I write? N solute divided by volume in ml multiplied by 1, 2, 3. Second formula for molarity. Okay. This is the second formula for molarity. Okay. Now at this point, I would like to pause for a little bit and highlight an important point. What is that important point? See, here you have volume, right? So in whichever concentration terms you have volume, in those concentration terms, temperature will have an effect on the value of that concentration. Right? Why am I saying that? See, Let me take the empty slide. So I'm just writing one statement. In the concentration terms, where volume is present, they change with temperature change. Means if you change the temperature, then these concentration terms will change. Why does that happen? Well, think about a little bit. See, if I have low temperature, then what will happen in low temperature? See, this is the solution, correct, which has some solute, some solvent molecules, right, and they are moving here and there. Right. At low temperature, these molecules have less energy, but if you increase the temperature, they have, when you increase the temperature, they have more energy, right? Now, because they have more energy, they will move more far apart from each other. So, earlier they were moving like in this much space. Now, they have more energy, so they will move in larger space. So, what happens is, now the same molecules move far apart. So, what happens as you increase temperature? Volume increases, right? So, what happens here, as temperature is increased, the volume is increased. Now, depending upon where the volume appears in the concentration terms formula, you will see that volume having an effect on the concentration term, which is in turn an effect of temperature. Now, let us see how molarity works. Remember this, temperature increases, this causes an increase in volume. So, right. See, you can see from here one thing, that molarity is inversely proportional to volume, right. So, if you increase temperature, volume will increase, but because it is inversely proportional to molarity, molarity will decrease, right. That is, this is the mathematical statement, right. Let us learn to write it in short. Mathematical statement of this statement: as temperature increases, volume of a solution increases and molarity decreases, right, and molarity decreases. I hope everything which is there here you have understood, except one thing. What is that one thing? Unit. I think that is also clear. Unit of N solute is moles, obviously liters. So, this can be written as moles liter inverse. That is the unit of molarity. Understand this definition, by heart it, memorize it, because this definition will come to you again and again in many forms in many chapters. So, there is one more way, right, of writing this. See, molarity is N moles by volume in liters, correct. Now, suppose I multiply numerator and denominator by 10 raised to power minus 3. So, we know that what is 10 raised to power minus 3? It is something called milli, denoted by small n, right. So, when you multiply it, you will get what? N millimoles divided by volume in milliliters. So, even this is a formula of molarity. When both of them are in millis, you do not need to convert the ml to anything, or the formula remains the same. That is why it is written there, number of millimoles of solute divided by volume in ml of solution. Even this formula can be used, right? Right. Now for this is called the dilution law, and how this dilution law came and what does it mean, I am going to explain further. See, for that let me take a empty slide, right? And see. So now we are going to talk about dilution law. How does this law work? Well, suppose I have 10 ml of solution. In this solution, I add 10 moles NaCl. So I had 10 ml of solution. In that, I add 10 moles of NaCl, right? So I make a nice solution, right? So you have a solution where 10 moles of NaCl added in 10 ml of total solution. Now suppose I dilute this solution. What do I mean by dilute this solution? There are two ways. First, I add in more amount of water. So I pour in water into this. Now after pouring water, right, volume of the solution, suppose I pour in 10 ml of H2O. If I pour in 10 ml of H2O, it becomes 20 ml of solution, right? But tell me one thing, the amount of water has increased, correct? But has the amount of solute changed? There was earlier 10 moles of NaCl. Right now also, what will be the moles of NaCl? 10 only, right? The moles of NaCl will not change. Moles of solute does not change on dilution. So moles of solute do not change on dilution, right? Moles of solute do not change. So here also I have 10 moles of NaCl, right? Now how to get this law from there? How to get this law from there? Simple. Moles of solute before dilution is equals to moles of solute. Okay. Before I do that, let me tell you, see, moles of solute divided by volume of solution is your molarity, right? From this we are going to derive another formula to find the moles, right, of solute. Cross multiply here, so you will get moles of solute is what? Molarity into volume of solution in liters. So this is another formula to find moles, right? Now coming back to the dilution, see, before you added water, moles of solute was same to the moles of solute after you added water. So I can say that N solute, what is this? Before dilution will be equals to N of solute after dilution, correct? So before solution, the volume is 10 ml, correct? So how you will write? Suppose the molarity here is M1 and molarity here is M2. So molarity of the solution is 2. So you will multiply the volume by molarity 1, you will get the moles before, and right, molarity by volume, molarity 2, you multiply it by the second solutions. Now here it can be ml or liters, does not matter, because even if you convert, that 1000 which you use will get cancelled out both sides. So this can be generally written as m1 v1 equals to m2 v2, which is your dilution law. Which is your dilution law. Right? So on dilution, moles of solute remain same. Because they remain same, hence the dilution law works. Right? Next, molarity of acid mixture or base mixture. Right? Let us see that. Molarity of, suppose now I take acid mixture. Right. So let me take an example. Suppose you have 1 molar solution of HCl. Volume of that solution is 10 liters, and you take this solution, add it into another solution which is 2 molar of again HCl in, suppose, again 10 liters. Right, 10 liters I have taken. So tell me, if I mix them each, so tell me the molarity of H plus or HCl in this mixture. Don't worry, same thing, number of moles, right? Number of moles means mixture moles of HCl divided by volume of mixture in liters, right? The formula remains same. The way to get to the calculation, that way changes slightly. So how you will find this number of moles? See, moles of mixture will be moles of first solution plus moles of the second solution, right? And newly I have told you how you calculate moles. You multiply the volume into molarity, right? So what is the volume of the first solution? 10 liters. Molarity is 1 plus volume of the second solution, again 10 liters, molarity is 2. So total moles will be 10 plus 20 equals to 30 moles. So N mixture is 30 moles. And what is the total volume? See, you mix 10 liters with 10 liters, total volume is 20 liters. So this will be 30 by 20. Answer will be 1.5 moles per liter. Right? So in this process, what I have done, see, this is M1, V1, this is what? V2, M2. So I added up this, right? In mathematics, we can write this as how? If I write it down now, molarity of mixture, I can write M1 V1 plus M2 V2, right? This is the total moles, and volume is V1 plus V2. This I can write by a symbol called sigma, where I equals to whatever number. Now here it is 1 to 2, right? Mi Vi divided by Vi, right? Addition of V. So this is how you find the molarity of mixture of acids, and if it is base, again you can follow the same formula. So before I move on to numericals, which are a number of numericals here, right, I would like to finish off the concentration terms, right? After I finish off the definition of all concentration terms, we will come to that, right? So the next concentration term is molality. Now molarity, yes, molality, it is an L, right? See this L here? It is an L, it's not R. So molality. Now this molality is represented by small m. Molarity by capital, molality by small. Obviously there is a difference. What is that difference? This is the formula. Number of moles of solute, number of moles of solute divided by weight of solvent. Weight of solvent, yes. I am not talking about weight of solution. In molarity, we had volume of solution. Everything solution, 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 solution. Till now, whatever concentration terms we have studied, always in the denominator you will get something of the solution. This is the only concentration term where you will not have solution, you will have solvent term in the denominator. And that too, weight of solvent in which unit? Kilograms, right? So this is your molality. And because here there is no term of volume, volume is not present, so molality is independent of temperature. What is the unit of molality? You have moles, right? You have moles, divide them by kgs. So unit is moles kilogram inverse, right? Moles kilogram inverse. They say that molality is the most accurate and theoretically the best method for expressing concentration. So that is about molality. Okay. Now moving on from molarity to molality, let me tell you a relation between the two. This is that relation. See this specific gravity. What is specific gravity here? It is actually density of solution in units of grams per ml or grams per cc. This is the, what is G mW? It is the molar mass of solute's molar mass. So molality can be related to molarity, where you can write it as 1000 into molality divided by 1000 into density plus molality and molar mass of solute, right? You can write it in this form or write it in this form. The choice is yours. Everything works, right? So this is the relation between molality and molarity. Now, another concentration term called mole fraction. Mole fraction, yes, it is a fraction. Fraction, what fraction? Let us see. This mole fraction, see, this looks like x, but it is not x. The term used for mole fraction is, what you do is, you draw a straight line like this, right? And then you do it like this. This is called chi. CHI, chi. This is the term used for mole fraction. It is not an x, right? So it is something called this. This is called chi. Right, mole fraction. If I have to find the mole fraction of A, I divide the moles of A by total moles, means moles of A and B. And yes, I'm talking about a mixture of A and B. So if you have a mixture of A and B, so if you have a mixture where you have A plus B, then in that mixture, mole fraction of A is number of moles of A divided by Na plus Nb, which is nothing but N total, right? Similarly for Nb, N total, right? This is called mole fraction. Now, for mole fraction, there is one more relation which is, I think, not mentioned here, but I feel it is important, right? See, if you add these two mole fractions, what you will get? Let us add them up. So, chi A plus chi B will be equals to Na, Na plus Nb plus Nb, Na plus Nb. This, my dear friends, comes out to be what? Comes out to be 1. A very important relation. Addition of mole fractions of all the components. Suppose we had a mixture of A plus B plus C also. Then also it will be chi A plus chi B plus chi C equals to 1. Mole fraction addition of all the components will give you an answer 1. Right? Right. Where is it useful does not matter. And mole fraction multiplied by 100. See, if you multiply it by 100, let me just, you just write this down and then I'll get to that also. If you multiply it by 100, so what is the formula? It is moles of A by N total multiplied by 100, right? Just simply what? Mole percentage of A. So this is your mole percentage A. This is your mole percentage B, right? This is your mole fraction, right? So in this way, sometimes you have another concentration terms called mole percentage. For that also we are covered in this lecture. And obviously, this is also mole, this is also moles, numerator moles, denominator moles, they cancel out each other and there is no unit for this. So it has no units. And obviously in moles, there is no term for volume. So they do not vary with temperature. If you change the temperature, mole fraction will not change, right? Right. Next is parts per million, right? Let me just remove all this and take a new slide because too much has been written on this. So next is your ppm. What is ppm? Parts per million. Number of parts of component by total number of parts of solution multiplied by 10 raised to power 6. What is 10 raised to power 6? Yeah, I don't have that much amount of money, but I know this is 1 million. See, parts per million is a general definition. See, this parts, do not get confused by this part. This part can be grams of solute present in total grams of solution, right? It can be gram, it can be weight, it can be volume also, right? So how can I do this? I can also write it as number of grams of solute by total weight of solution also in grams multiplied by 10 raised to power 6, right? Same I can write volume. So now what do I mean by parts per million? It means, let us understand what it means, right? If you have written this down, I'll just erase this, right? No need of erasing also, I'll do it in the same thing. So, weight of solute in grams. Suppose total weight of the solution now is 1 million grams. 1 million grams. So 10 raised to power 6 grams. This gets cancelled out. So what does the definition of parts per million now is? What is the definition? See, we have been doing this throughout this lecture. So I think you can understand this. It is the weight of solute in grams, if you are talking about grams. Weight of solute in grams present in 1 million or 10 raised to power 6 grams of solution. Weight of solute in grams in 10 raised to power 6 grams of solution. So if I have, understand this, see, if I have the complete ocean as my solution, right? Let me delete this. See, if I have complete ocean as my solution, right? Ocean has many salts. It is actually the most widely available solution. Out of that complete ocean, if I take out how much? 10 raised to power 6 gram of solution. I take it out, okay? I fill it up in buckets or some bucket. Now, that 10 raised to power 6 gram solution, if I heat it, on heating the solution goes up, sorry, the water from the solution goes up. So, water is removed. So, whatever salt is left, whatever weight is there of this, salt, right? Whatever weight is there of this salt, that will be my ppm value, right? So 10 raised to power 6, it can be 10 raised to power 6 grams, or it can be 10 raised to power 6 mLs, 10 raised to power 6 liters, whatever you want to take, but that is what we mean by parts per million, right? So now, most of the concentration terms we have covered. Now there will be many numericals shown on the screen, right? Like this, right? I want all of you to pause your screens for a little bit. Even the correct answers are given here. So pause the screen for a little bit and try and solve these numericals yourselves, right? like this one also, right? This one, this one, this one, and right. So let me solve at least one, otherwise, okay. 0.1 gram mole of urea is dissolved in 100 grams of water. The molality of the solution is. See, when you see 1 gram mole, no, 1 gram mole, it is just a fancy way of saying the number of moles. So they are given you 0.1 mole of urea, right? 0.1 mole of urea they have given you. What is urea? Urea looks somewhat like this, right? So it will be 14, 2 nitrogens plus 4 hydrogens plus 1 carbon plus 1 oxygen. If you add them up, you get around 60 grams as the molecular weight of urea. So this is the moles of urea dissolved. Acha, this is it's a direct question. I don't need to calculate the molar mass also. 100 grams of water, right? 100 grams of water means how many kgs of water? Right? 0.1 kgs. Right? So just simply divide 0.1 moles by 0.1 kg, you will get 1 molar, right? 1 molar solution is what you get. So, right, this is the correct answer. Okay. So, 6, again a urea based question, 6 grams of urea is dissolved in 90 grams of water. So 6 grams of urea, you have to find the mole fraction. What do I mean by mole fraction? See, mole fraction of solute means solute is urea, moles of urea divided by moles of H2O plus moles of urea. So for that, calculate the moles of urea first. 6 grams by 60 grams per mole. The molar mass we just calculated 0.1 mole of urea. 90 grams of water. So what is the moles of water? Molar mass of water, right? Moles of water is 5 moles. Now calculating mole fraction is easy. 0.1 divided by, add this mole to this mole. .1. So the answer will be 1 by 51. Okay, there is no unit for mole fraction, right? So 1 by 51. Right. So these are some questions. There are some more questions which were there in the slide previous. Let me just display them also for your understanding. Right. See, this is one more question, right? Try and solve all these questions in your home. Let me solve one of this question, like this question, where you have 10.6 grams of Na2CO3, right? Dissolving in 250 ml of solution, molarity of the solution you have to find, right? Molarity we need, moles we know, and volume of solution we need. What is the moles of Na2CO3? See, if you calculate the molar mass of Na2CO3, sodium is 23 plus 12 plus 3 into 16. This will come out to be around 106 grams per mole, sorry. Molar mass unit is per mole. So, what will be the moles? 10.6 divided by 106, right? This comes out to be 0.1 mole. Put that 0.1 mole here, divided by 250, multiply it by 1000, you'll get your answer, right? So this is one, I think this is another one. So whatever concepts I have discussed in today's class, all of them can be used to solve all of these questions as a homework, as your practice. I want all of you to solve this question. We are towards the end of this session, right? Specifically this one also, right? To solve all of these questions so that you have a thorough practice on what? Concentration terms. And thank you for listening to me patiently. And if you liked, understood all the concepts that I have discussed till now, well, what is the next natural step? Well, the next natural step is to get connected with us, that is Knowledge Hub by Sri Chaitanya. Enroll yourself in our courses by scanning this QR code. So bye for now till I meet you again in the next class.